Vaishnavi, hello. Vaishnavi, you are the host, so you have to enable and allow me to do screen sharing.
Just a second. I'll change you to host.
Yeah, I got it now. Okay, now I have 8 questions and only 2 of you have joined. So while we wait, please answer these questions. Put the correct option, put question number. So this is question number 1, this is 2. These are MCQs based on what we have learned. So I want you to write the answers in your notebook and then we will discuss later. Have you answered, all 3 of you? Hari Raghav, please write the answers of the questions in your notebook. Question number 1 and 2 are there on the screen. Vaishnavi, are you doing it? Shall I change the screen? Hariharan, have you done it?
Thanks.
Hari Raghav. Hello.
I'm doing it.
Yeah, do it. Vaishnavi.
1 minute.
Okay. I'll go to the next one now. This is 3 and 4. Please put the question numbers. Shall I change? Hariharan is getting bored. He has finished it already. Hari Raghav and Vaishnavi, are you done with question 3 and 4? Hello. Vaishnavi? Yeah.
Yes.
Shall I go to the next screen? I'm going changing now. Next is 5 and 6. Quickly write down the answers. These are easy. Okay. Now I'm going to the last 2 questions. 8 I have given. Just for your information, this word you are not familiar with. So I will tell you what it means so that you can be sure of what your answer is. Racemization means no, I should take a back one. It means 50% retention plus 50% inversion. If we have both the things together, then we call it racemization. All right, all of you are done now. Okay, now since Hari Raghav seems to have completed it first, please tell me your answers, Hari Raghav. Can you? Just 1 to 8. Can you tell me your answers, A, B, C, D? Not Hari Raghav, Hari Haran. First, you tell me your answers.
Ma'am, 1 chloropropane.
No, you don't tell me, just tell me the numbers. 1 to 8, tell me the numbers, A, B, C.
B, ma'am.
First one, you have written B. Second?
Second, I have written C, ma'am.
C. Then third?
C, ma'am.
C. 4. Quickly tell me. 4 is? What is 4? If you have not written, tell me. 4 you have not
I have
written, then
written the
6.
letter, ma'am. The
You
letter I
haven't
have
written
written,
the
ma'am.
letter. Okay.
Yes,
4. Yeah, 4. Now can you tell me?
I written A, ma'am. A,
4
ma'am.
is
A, ma'am.
which? 4 is A. Okay. Then 5.
5D, ma'am.
5B and 6.
D, ma'am. D, ma'am.
5 is D, and 6
ma'am.
is
D, ma'am.
D.
D.
D for Delhi, isn't it?
Yes, ma'am.
7,
B, ma'am.
B for Bombay, and 8,
D, ma'am.
8 is D, D for Delhi. Now, Hari Raghav, you tell me. Now we will discuss the answers and we'll quickly do it. Hari Raghav, tell me. A, B, C, D, you tell me from number 1.
Yes,
A, first one is? What is first one?
it's B, ma'am.
B. Second? Second one is? Tell
C.
me. C. Then third one?
Ma'am, it's C, ma'am.
C. Third is also
Yes.
C. Then fourth?
Fourth I didn't write, ma'am.
Okay. Fifth?
Ma'am, it's B, ma'am. It's B for
B.
ball.
Okay. C. Sixth?
Ma'am, 6 also I didn't write.
Okay. 7? Seven?
Ma'am, it's B. It's B, ma'am.
B. And 8?
8 I didn't write, ma'am.
8 you didn't write. Okay. Now it's Vaishnavi's turn. Quickly tell me. We are wasting a lot of time. Quickly, Vaishnavi, tell me 1.
Ma'am, A.
A.
Second one is B.
Hmm.
Third one is C.
Hmm.
Fourth one is A.
Hmm.
Fifth one is B.
Hmm.
Sixth one is D.
D.
Seventh one is B.
B
And
for
eighth one I
Bombay.
don't know. Yes,
Seventh
ma'am.
is B for Bombay. And 8th one you don't know.
Yes,
Okay.
ma'am.
So Vaishnavi, out of you have got 7 out of 8. 1 you didn't write. Others, all that you wrote are correct. All right. Hari Haran, you have got out of 8, you have got 5 right and 3 wrong. Okay, 5 out of 8. And Hari Raghav, you have got 2, 3 right, and rest you did not write. Okay. So now we will quickly discuss the answers and then we will go further. Now see the first one. Hari Raghav and Hari Haran. Both of you wrote 1-chloropropane, right? You wrote 1-chloropropane. Now this was a trick question. It was reaction of HCl in presence of peroxides. So I told you that the effect of peroxides is only seen when you have what? HBr, right? Vaishnavi, you chose the correct answer because it has to be 2-chloropropane, because if this peroxides here is given only to confuse you. The effect of peroxide is not there on HCl. So HCl, it will add by Markovnikov's rule only, and 2-chloropropane will be the right answer. So here the correct answer was A, 2-chloropropane. Then second one, it is ethyl chloride when it is reacted with sodium in presence of dry ether. So what is ethyl chloride? See, both of you wrote ethane. So ethane is Hari Raghav and Haran. Both of you got it wrong because you wrote ethane. But we are saying ethyl chloride. So ethyl chloride, when it reacts with sodium, always 2 molecules react, right? This is the reaction. So this is a reaction which is known as Wood's reaction. So in the Wood's reaction, what happens? Sodium and chlorine, they will come out as NaCl, and what will be remaining? CH3, this C2H5 is CH3, CH2, CH2, CH3. So this is butane, right? This is butane. So you have to be careful and understand the reaction. The reaction is Wood's reaction that we did towards the end yesterday. Now this one, all of you got right. The answer is Grignard reagent. So all of you recognize this is Grignard reagent. Then the fourth one, two of you got it right. That is A-ethoxyethane. Hari Raghav, did you understand? Ethyl bromide, this is C2H5Br. When it reacts with C2H5ONA, this is sodium ethoxide. You get an ether, C2H5O, C2H5. And this is called ethoxyethane. This is ethoxyethane. Then this question, all of you got right. That's very good. Nucleophilic substitution reaction, right? Then the sixth one, two of you wrote it and both of you got it right, which will show SN1 reaction. SN1 reaction is always shown by tertiary alkyl halides. So that is why D is the correct answer. Then the next one, all of you got it right. Synthesis of alkyl fluoride. I told you Finkelstein is not fluoride, it is Swartz. So all of you remembered that. That was very good. And the last one, only Hari Haran answered it, but it is not correct. Which is the answer, Hariharan? I did not understand. Did you write the answer as B or did you write it as D?
D,
If you
ma'am.
wrote it B. So the answer is B.
D, ma'am. D, ma'am.
So answer is actually B. SN1 reaction of alkyl halide. Now the whole thing that I was trying to teach you yesterday about optical isomerism. What did I say? SN1 and SN2. There are two types of reactions. This is shown by tertiary, which you have understood, all of you have understood correctly. And this one is always shown by primary. Now this SN1 reaction, it shows and since the reaction occurs in two steps, the intermediate carbocation is formed, which is planar. And so you can get product by attack of a nucleophile from the front or from the back. So there is 50% retention and 50% inversion in SN1. So SN1 is retention plus inversion, I plus R plus I both happen. And in SN2, what happens? It is always inversion because one reagent is, one group is going out from one side and the other is coming from the back. Always there's a back attack. So there is always inversion of configuration. So in SN2, it is only inversion. In SN1, it is retention plus inversion. 50% retention, 50% inversion. This word I didn't mention yesterday. This is known as racemization. When you have 50% of one isomer, 50% of the other, we call it racemization. Okay. So this you will be able to understand more with practice and a little more when we learn something else also. Okay. I mean, like when you go through the notes and all, you will understand it better. So yesterday we finished those reactions in which we were doing reactions of alkyl halides with metals, and it's very good. You understood what a Grignard reagent is. When an alkyl halide reacts with a metal, we get a Grignard reagent. And the other reaction was reaction of alkyl halides with sodium, and that is a Wood's reaction where the product is always an alkane and the number of carbon atoms in alkane is double the number of carbon atoms in the alkyl halides. Now, since two of you did not get it correct, let me talk a little bit about this Wood's reaction again. Wood's reaction. So in the Wood's reaction, the first thing is if I take R, which is alkyl, and I take X, and I react it with sodium, two molecules of alkyl halide will react. In presence of dry ether, which acts as a solvent, I get 2NaX, right, which is an inorganic product, and the two R, they will combine with each other, R. So if I have CH3Cl plus 2Na and I have ClCH3, then ClCH3 I have written the mirror image, inverted and written. So what will I get? I'll get 2NaCl plus CH3CH3. So I had methyl chloride. So what did I get from methyl chloride? I got ethane. Right? Now supposing I start from ethyl chloride, CH3CH2Cl plus 2Na plus ClCH2CH3. Then what will I get? I'll get 2NaCl nevertheless, but 2 carbon atoms here and 2 carbon atoms here. So this part will go away. You can remove this part and you can link this carbon atom, the 2, and here this is 1 and 2, and here this is 1 and 2. So you link these two. So you get CH3, CH2, CH2, and CH3. That is the product that you get. Now supposing I have an alkane like this, CH3CH, alkyl halide like this, 2-chloropropane. And I reacted with sodium. Now I have to write the inverted image of this. So I will write Cl here and then CH, CH3 and CH3, 2-chloropropane. Then what will happen? I will remove this NaCl and connect this carbon and this carbon, right? These 2 carbons I will connect. So what will be my product? My product will be CH3, CH, CH3, and then again CH, CH3 and CH3. You can see this part came from the first molecule, this part came from the second molecule, and I have linked them by a bond. What is the name of this compound? 2,3-dimethyl butane, right? But how many carbon atoms does it have? Your alkyl halide had 3. And how many carbon atoms does a product have? 6 carbon atoms. So always in the product you will find, you will get double the number of carbon atoms. So if you want to prepare an alkane with double the number of carbon atoms from the alkyl halide, you will always get 2-chloro. You will use Wood's reaction. Don't forget this. So there is very often a question which is asked here. You know, these are called road map questions. So I will give you road map question. Okay. So what is a road map question? I am talking about there is this reaction where you have CH3, CH2, CH2. No, let me make it an alkene. So you have this alkene propene, right? And to propene, I add HBr, right? No peroxide, just HBr. I get A. And A, I react with sodium and dry ether, right? I get B. You have to identify A and B. Now I take propene, CH3, CH double bond, CH2. And now I add HBr in presence of peroxides, right? I get A, and A with sodium and dry ether, it gives me B. You have to identify A and B here. Or my question could be, are A and B and B same in both? Obviously, they are not same. So let us identify the 2 products, okay? So in the first case, when I add HBr to propene without peroxides, what will be the product? Now tell me, Hari Raghav, what will be the product?
It's CH3, CH2, CH2Br.
No, but there is no peroxide here, no, Hari Raghav. So it will be
Sorry, ma'am.
simple.
CH3 single bond Br.
And then CH3. This 2-bromopropane. Did you understand this? 2-bromopropane.
Yes,
And just see here in the second case, when I write a product, in this one, there is peroxide. So there will be anti-Markovnikov. So what will I get? CH3, CH2, CH2Br. Can you see the difference between the two? I have added HBr directly without peroxides. My product is and according to Markovnikov's rule. Then I added HBr without peroxide. My product is this one, which is anti-Markovnikov's rule. Okay, what is Markovnikov? Negative part of the reagent will go to that carbon which has less number of hydrogen atoms. Here it is going to that carbon which has more numbers. So this is anti-Markovnikov. This is called the Markovnikov product. So we call it MKP, Markovnikov product. And the second one we call it AMKP, that is anti-Markovnikov product. Now this one, when it undergoes reaction, Wood's reaction with sodium and dry ether, then what will I get? I will get two molecules are there. Two molecules will take part in the reaction. So CH3, CHBr, and here, no, let me write. CHBr is here and CH3. And another molecule CH3, CH3 and Br is here, right? Now when they react with 2Na, what will happen? This part will disappear. Okay, so let me remove this part. So what will happen? I remove this part. Now this carbon and this carbon, they will join together and they will form a compound. So what is my compound? 2,3-dimethylbutane. All right. Now, in this case, what will I get? In this case, I will get a product. So this is one, and the other molecule is where it is plus 2Na, and the other is Br, CH2, CH2, CH3. So what will be the product? I will get hexane, CH2, CH2, one molecule, and from here CH2, CH2, CH2. Now you see this has also 6 carbon atoms. This also has 6 carbon atoms, isn't it? 1, 2, 3, 4, 5, 6. So both have 6 carbon atoms. So the product which I formed here, this B and this B, both have 6 carbon atoms, but they are isomers. They are not the same compound. This is hexane and this is 2,3-dimethylbutane. This is a very typical CBSE question. They will always ask. Okay, so please understand. First, these are the places where there are different products. So you should be able to figure out. So here with HBr, I get 2-bromopropane. That with sodium and dry ether will give me this branch product. Here with peroxides, I'm getting 1-bromopropane. So you get normal hexane. Okay, so that is. So please practice and read so that you understand all these things. Okay, so this is the type of questions which can come. Now we are left with the last type of reactions of alkyl halides, and these are called, so all the reactions that we learned till now, they were all first nucleophilic substitution reactions, and then we learned SN1 and SN2, and then we learned the reactions of alkyl halide with metals. Now we will learn the elimination reactions. Elimination reactions. Elimination reactions. So alkyl halides can also undergo the reactions which are called elimination reactions. So say for example, there is the most important elimination reaction is one where I have methyl, supposing I have say ethyl chloride, and I reacted with alcoholic KOH. Okay, we have learned when I reacted with aqueous KOH, what happens? Cl is replaced by OH. But now I am doing alcoholic KOH. Now this alcoholic KOH helps me in an elimination reaction. Elimination reaction is a reaction where the compound is saturated, but then 2 components from the compound are removed, so a double bond is created. So this is saturated, but the product that you get is unsaturated. So if the product is unsaturated, then the reaction is elimination reaction. So from here, what do I remove? H. And from here, what do I remove? Cl. So if I remove H and Cl, I have removed two components from adjacent carbon atoms. So this is unsaturated, this has lost something, this has lost something. So they both share now a double bond. So the compound that I got here will be CH, right? CH2. So this type of reaction is called elimination reaction. Since I remove a hydrogen and a chlorine, I call it D. D means removing. Dehydrohalogenation. Dehydrohalogenation reaction of alkyl halides. These are very, very important, from where you make alkenes from alkyl halides. You have learned these reactions in class 11 when you learn the preparation of alkenes. Okay. Now this elimination, you must remember, always happens between two adjacent carbon atoms. Okay. So what I mean is that if I have an alkene like this CH3, CHCl, CH3, right? So here there is no problem. Cl will go from here and H from the adjacent carbon atom. So what will happen if I take alcoholic KOH? Then it will remove Cl from here and H from here. So what will I get? CH3, CH double bond CH2. It could remove it from the left side also. In that case, I would get CH2, CH, single bond CH3. This and this, they are same compound. There is no problem. Same thing. So I will, when I remove a halogen, I will always remove a hydrogen from the adjacent carbon atom. Now, sometimes there is a problem. Sometimes the problem is that I have a compound like this, CH3, CH, Cl, CH2 and CH3. Now I have a problem. What is the problem? That if I remove Cl and one H from here, then what will I get? I will get CH3, CH, double bond CH, CH3. This is 2-butene, right? And supposing I remove Cl from here and the other from the first carbon atom, then what will I get? CH2, double bond CH, CH2, CH3. This is 1-butene, right? So I get 1-butene and 2-butene. They are two different products. So I should know which will be my major product. So the major product, for learning the major product, we find there is a rule which is Sadzev's rule. Just like Markovnikov's rule, this is Sadzev's rule. And when I was teaching Markovnikov's rule, I told you a simple rule in organic chemistry is poor becomes poorer. Poor becomes poorer, right? What does it mean? That hydrogen will be eliminated from that carbon which has less number of hydrogen atoms. So there are two carbon atoms. Which carbon is poor? The carbon which has two hydrogen. This carbon has 3. So which is poor? This carbon is poor. So this will be the major product. So what is the major product? The major product is formed in such a way that hydrogen is removed from that carbon which has less number of hydrogen atoms. If you can't remember the whole rule, remember the rule of the nature is poor becomes poorer. Okay, so you will get 2-butene as a major product. This type of elimination reaction is also called beta elimination. Beta elimination. Why do we call it beta elimination? Because the alpha carbon is the one where this is the alpha, and beta means the adjacent carbon atom. So always hydrogen will be removed from the adjacent carbon. You cannot remove chlorine from here and hydrogen from here. This is not possible. It has to be removed either from this side or from this side. And what will be the major product? The major product will depend on the number of carbon atom on the number of carbon atoms with the number of hydrogen atoms. So whichever carbon has less number of hydrogen atoms, that will lose, and so you will get the product based on that. So let me give you just one more example. So the example here. So supposing I have CH3, CH3, and here I have Cl, and here CH3. This is easy with alcoholic KOH. Vaishnavi, what is the product that I will get?
Ma'am, CH2, CH2 double bond, CH3 down CH3.
Right. So this is 2-methyl 1-propene, right? 2-methyl propene. Okay. So this type of reaction is known as substitution, elimination reaction. So alkyl halides, in addition to nucleophilic substitution reactions, they can also show reactions which are elimination reactions. So three types of reactions of alkyl halides we have learned. One is substitution reaction, nucleophilic. The other is reaction with metals. And the third type of reactions is nucleophilic substitution reactions. Okay. Now we will just quickly, make a small table for you to remember everything, all reactions that you have learned. So I am going to take a simple alkyl hal. Yes.
Ma'am, for the before reaction,
Tell me.
for the before reaction, it will only react with potassium hydroxide or any other element. Ma'am.
Only this reagent, alcoholic potassium hydroxide. Alcoholic solution.
For this only
of
we get elimination reaction.
Yes. Now suppose elimination reaction of alkyl halides, right, is always only with alcoholic potassium. Now here you should remember a very important thing. Supposing I have CH3, CH2, CH2, Cl. There are two possibilities. In the first case, supposing I take aqueous NaOH, or I should not, or aqueous KOH. That means I take a solution of potassium hydroxide or sodium hydroxide. Then my product will be, Cl will be replaced by OH. So I'll get CH3, CH2, CH2, OH. I'll get an alcohol. But if I take alcoholic KOH, not even NaOH, only alcoholic KOH, then I get CH3, CH double bond CH. So the first reaction with aqueous KOH, it was nucleophilic substitution. What I get here, this one is elimination. So this also, there is a comparison you should remember. Elimination is by alcoholic KOH and substitution is by aqueous KOH. Okay, so aqueous KOH removes the OH.
Yes,
And remove the Cl and replaces by OH. But alcoholic KOH, it removes the H and the Cl. Both are removed. Okay, so that is why the product is elimination. So so now I want to draw a small table and I want you all to draw it along with me, and then you can practice with this. In your assignments, I will send this to you for practice also. There is a very good assignment which has been uploaded based on the whole syllabus, so whole chapter. So you should try. All types of questions are there, and that is a very good one. So I'm taking CH3CH2Cl in the center. And on this side, I am writing methods of preparation. Okay, 1, 2, 3, and 4. Okay, I want you to prepare this CH3CH2Cl. I want you to prepare from ethene. Okay, how will you prepare it from ethene? I want you to prepare this from ethyl alcohol. And I want you to prepare, let us do only 2. first to begin with. Only two methods of preparation. So CH3, CH2, OH. Now can you tell me the answers? How will I prepare from ethene? By addition of HCl. I will just add HCl. And here I will add PCl5, which will remove the OH and replace it by Cl. So these two are methods of preparation. Now I would like you to draw here the products. Various things that we have learned. There are 10 important reactions. I'm going to write here 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let us do this much. So first I want you to prepare from here an alkane. So CH3, CH2, CH2, CH3. This is the alkane I want you to prepare. Second, I want you to prepare from here the alkene. The third alkyne we will leave. Alkyl halide, this is now alcohol, CH3, CH2, OH. Then cyanide, CH3, CH2, CN. Then I want you to prepare isocyanide, CH2, NC. Then I want you to prepare CH3, CH2, MgCl, a Grignard reagent. Then I want you to prepare CH3, CH2, O, CH2, CH3. Then I want you to prepare from here nitroethane, CH3, CH2, NO2. And I also want you to prepare lastly CH3, CH2, O, CO, CH3, and ester. These are the various things we have learned. Now let us see. How can I prepare? So this is my reagents. These are the reagents that you have to memorize and learn. Now, which reagent can convert alkyl halide into an alkane with double the number of carbon atoms? Can you tell me? Any one of you, quickly answer.
Name, ma'am.
Name
Na,
reactions.
2Na.
Yeah, 2Na and sodium and dry ether. The name of this reaction is
Wurtz, ma'am. Wurtz reaction.
Wurtz reaction. Now, how will I remove HNCl? By elimination. Which reagent? Alcoholic.
Alcoholic, ma'am.
Not aqueous, alcohol. Here I will
Alcoholic.
use aqueous KOH. All right. Here what will I do? NaCl.
KCN. Oh,
KCN or NaCN, anything, both. I'm afraid of potassium cyanide, so I use sodium cyanide. Okay. Now NC.
CN, ma'am.
AgCN. Right? Now, here what will I do? Just magnesium, right? Here what will I do? CH3, CH2, ONA, sodium ethoxide. Okay. Then here I will use AgNO2. And the last one, I will take CH3COOH. Okay. So these are the methods by which I can prepare different compounds from alkyl halides. And drawing this chart also is very useful. What does it tell you? That if I say from ethyl alcohol, how will you prepare diethyl ether? So first ethyl alcohol to ethyl chloride and then diethyl ether. Supposing I say from ethyl alcohol, how will you prepare ethyl cyanide? So ethyl alcohol to ethyl chloride and then to ethyl cyanide. So this also helps you in looking at the whole picture. Okay. So this is only using 2 carbon atoms. You could make similar with 3 carbon atoms. And that is how we will, understand easily the alkyl halides. Okay. Now we have completed the alkyl halides. Now I want you to do the next one, and that is now the aryl halides. So now we will start with aryl halides. Okay. Now, in case of aryl halides, first what is important to understand that aryl halides are those compounds of halogens where the halogen is attached directly to the benzene ring, directly to the benzene ring. So what are the methods of preparation? First, let us look at methods of preparation. Now, when you're preparing a compound which contains a benzene ring, you will always have to start with at least the benzene ring. You can't synthesize benzene ring, is not easy to make. It is always obtained from coal tar. So you will at least start with benzene. So first method is from benzene. Okay. So how will you prepare from benzene? You take benzene and you add chlorine to it. It is called chlorination, or any halogen. I have taken chlorine, so chlorination. And this you have learned in class 11 when you add chlorine in presence of anhydrous AlCl3. In presence of what? Anhydrous AlCl3. Right? What happens? What is the product? You get one hydrogen from here is removed and it reacts with chlorine, and chlorine takes the place of hydrogen. So it is a substitution reaction. You get Cl on the benzene ring and HCl. This is chlorobenzene. This is known as chlorobenzene. Now we have just, one more method of preparation, which I actually speaking don't like to teach at this stage, but it is given in your textbook, so I will teach. So there is this compound which any one of you who knows the name of this compound should tell me what is the name of this compound.
Aminobenzene, ma'am.
Aminobenzene. It is also known as aniline, right?
Aniline.
Now this aniline, it has one reaction with NaNO2 and HCl. If it reacts with NaNO2 and HCl, it changes into this compound N2 plus and Cl minus. This is known as benzene diazonium chloride. Now this you will understand better towards, when we are doing compounds containing nitrogen, then you will understand this reaction better. But since it is given in your book, you may have to answer questions in your first semester itself on this, so you should know this reaction. So this reaction is of aniline. Aniline in presence of NaNO2 and HCl. More importantly, between the temperature of 0 to 5, it makes this very important compound which is called benzene diazonium chloride. N2 plus Cl minus, it is a salt. So this benzene diazonium chloride is so useful because it is very unstable. You can easily remove the nitrogen from here. So there are various ways of removing the nitrogen. So if I take CuCl and HCl, right, then easily I get Cl here, right? If I take CuBr and HCl, CuBr and HBr. Then I will get here Br. I can replace it with Br. So this group which is present here is easily replaced by a halogen. So I can get alkyl halide, I can get aryl halide, chloride, then bromide. Then the third possibility is if I take Ki here, then it can be replaced by I. It can be replaced by iodine. These reactions, all of them, they were studied by a scientist called Sandmeyer. So that is why they are called Sandmeyer's reactions. Okay, Sandmeyer's reactions. So if I take a compound which has fluorine, it will be replaced by F. If I take iodine, it is replaced by I. If I take Br, it will be replaced by Br. Cl, it will be replaced by Cl. Copper actually here sometimes acts as a catalyst. So easily it helps the reaction. So that these are called Sand-Mears reactions. So Sand-Mears reactions are those reactions in which benzene diazonium chloride can be converted into a aryl halide easily. So this is the second method of preparation of aryl halides. Okay, so preparation done. Now we will talk about the properties of aryl halides. Properties. Now, aryl halides can show reactions like alkyl halides. So if I look at chlorobenzene, now we will just look at the structure of chlorobenzene carefully. This is chlorobenzene. And you know this chlorobenzene has these 3 lone pair of electrons around it. Okay, this is the structure of chlorobenzene. So it can undergo reactions because of, just like alkyl halides, this bond can break and Cl can be replaced by something else. What are those reactions called? They are called nucleophilic substitution that you learned also with alkyl halides. But you should understand whether the reaction will happen as easily as in case of alkyl halides. So we have to understand that. So for understanding that, you can see here, this is a conjugated system. What is the meaning of conjugated system? Conjugated system are those, benzene is very special example. Conjugated systems are those where you have alternate double bonds and single bonds in a system. So whenever there's a benzene ring, there is a double bond, single bond, double bond, single bond. So such alternate double bond and single bonds, they are called conjugated systems. Now, please tell me, in class 11, have you learned this resonance effect?
Yes, ma'am.
Resonance or
Yes, ma'am.
mesomeric effect. Okay, so we have to understand that whenever a substituent is attached to the benzene ring, it will show some sort of resonance effect or mesomeric effect. So what happens in case of chlorine? This is also something which you should know thoroughly from your class 11. So I will show you the resonance structures, how to draw the resonance structures of chlorobenzene, then we will talk about the rest. So to draw the resonance structures of any compound which has a benzene ring, first thing you should do is you should draw 5 skeletons. Skeleton means the ring only with the element, no double bonds or lone pairs. So I have drawn one here, one is here, and I will draw 3 more. So 1, 2, 3, right? And this one is 4, this one is 5. So 5, first you should always draw the 4 skeletons, or 5 skeletons. So I have drawn 5 skeletons, Cl here, Cl here, Cl here. None of them is chlorobenzene. I have just drawn the outline with just the element, skeleton. Now in the first one, what you do, you draw the double bonds like this. And the last one, you shift the position of the double bond. So when the double bond is between, a horizontal double bond is at this side, here the horizontal double bond is like this. Then show the lone pairs, all the lone pairs in the first one and the last one. So what is our objective? Our objective is to draw the structures which are intermediate to how the first one, this is first, this is second, this is third, this is fourth, this is fifth. How the first one goes to the last one. You have learned it in class 11. We are just revising it. Okay. Now, when a conjugated system, what is the rule? When a conjugated system is singly bonded to an electronegative element, then the electrons move towards the conjugated system. So the electrons will move towards it. So arrows, you know what these arrows indicate. So curly arrows, these are called curly arrows, not straight, curly. So what will happen? These electrons will repel these here, and this will come to take place here. So what will happen? The lone pair will change into bond pair. This bond pair will change into lone pair. So here you will get negative charge and here a double bond. So this carbon chlorine loses. So this gets a positive charge. Here no change. And here no change and here no change. So this is the first resonance structure. Carefully see and practice doing it. Now next is this lone pair becomes the bond pair and this bond pair becomes a lone pair. So what happens? This will become a double bond. This is no change, and here these two electrons, so negative charge, and here anyway positive charge and no change. Now the next thing, this will come here and this will come here. So this will become negative. A bond here, this no change. Right? And now the last one is these electrons go back to their place and these come in the place. So you get the last structure. So all these structures are equivalent resonance structures. So you should separate them by double-headed arrows. So chlorobenzene, these are the resonance structures of chlorobenzene. You should practice writing them because there are many give reasons questions which come from here, chlorobenzene. Now, what does these resonance structure, what are the inferences that you can make from these resonance structures? So the first inference here is that in all these resonance structures, if you see carefully, you know, I hope all of you know that if there is a benzene ring, let me just go to the next page and explain. We have done this in nomenclature, so you know it. So if you have a benzene ring here and there is a substituent X here, then this position is ortho, this position is meta, and this position here is para. All of you know that? See, children, your cameras are off, so I cannot see your faces. I don't understand whether you are listening or not. So at least sometimes you should say yes or no. Something you should say, children. It is so difficult to teach a wall. I can't see the children. I can't see you all. So at least there should be some communication. My request to you is there. Please. For 1.5 hours, I'm making effort to talk to you. And you are all just putting your camera off. What is the big problem? If I close the camera and then just show you the slides and don't talk to you, how will you understand? Tell me. So you should, if there has to be the first class I told you, the class can be effective and interesting only when there is two-way communication. If I only keep talking for 1.5 hours, you will feel bored. I also feel bored. You are not answering at all. Right? So sometimes at least yes or no, you should say something. Right? So please cooperate, then otherwise there's no point in having these classes. So now you see, so here what do you observe? You observe that there is a negative charge where? On the ortho position. Here, where is the negative charge? On the para position. Here, where is the negative charge? On the ortho position. So where is my negative charge placed? It is placed on ortho and on para position. So what is the influence of Cl? The influence of Cl is that it is ortho-para directing. Ortho-para directing. Have you heard of this word earlier? Ortho-para directing. Have you heard of this earlier, children?
Yes,
Tell
ma'am.
me.
Ortho-para
Yes.
directing groups.
Or ortho-para directing. So when there is a substituent present on the benzene ring, it acts as a director. It decides where the next reactant will come on the benzene ring, whether it will come on ortho position or it will come on para or it will come on meta. That is the decision which or that is the direction which this Cl takes. So in case of Cl, what do we realize? We realize that Cl is ortho-para directing. So that is a very important thing to understand, that what is the influence of Cl. The first inference we take out is that Cl is ortho-para directing. Okay, we will understand just now what it means. The second thing what you understand from here, drawing the structures, what is the advantage? The second thing that we understand is that you look at this carbon-chlorine bond here. Everywhere the carbon-chlorine bond is becoming like a double bond, right? In out of the 5 structures, in the 3 structures, 3 of the resonance structures, you realize that carbon-chlorine bond is a double bond, like a double bond. It always requires more energy to break a double bond compared to a single bond. So what is the second inference that you make? The second inference that we make is that this slide I must delete. Let us go to the next slide. What happened? Yeah, so the second inference that we make is that carbon-chlorine bond, the carbon and chlorine bond has a double bond character, okay, double bond character, due to which it is difficult to break, right? So if I have a reaction of say CH3Cl with NaOH, aqueous NaOH, what did I say? Cl will be replaced by OH. So what will I get? CH3OH plus NaCl. You don't have to heat or do anything. This reaction takes place easily. But if I take chlorobenzene, right, Cl, right, this bond breaks very easily, but this bond does not break easily. So if I take aqueous NaOH, right, here also it was aqueous, then I should get what? Cl should be replaced by OH. It also happens, you plus NaCl, but this does not happen easily. So what do you need? You need to have high temperature and high pressure. This happens only at high temperature and high pressure. So all reactions of alkyl halides are shown by aryl halides also. But what is the condition? The condition is that the reaction takes place only at high temperature and high pressure. So on the arrow, you will always have to write high temperature and high pressure. Then only the reaction will take place. And the products you can always guess. So here again, we will we will draw a table and see. So this is my chlorobenzene, right? And if I react it with any of the reagents, right? If I react it with any reagents here, say for example, I take NaOH aqueous, then I will get here OH, but at high T and high P, right? If I take CuCN instead of NaCN, CuCN, doesn't matter. I will get here Cn. If I take AgCN, what will I get? I will get here, instead of Cl, I will get Nc. All will be at high temperature and pressure. Here also high temperature and pressure. Okay, if I take ammonia, then also instead of Cl, I will get NH2 here, but again at high temperature and pressure. So why are we using high temperature and pressure? Because the carbon-chlorine bond acquires a double bond character due to resonance. Okay, so due to resonance, any question of any aromatic compound, you have to always remember you have to use the word resonance. So because of resonance, this bond doesn't break easily. So we need special conditions like high temperature and pressure to bring about which reaction? nucleophilic substitution reaction. So the question can also be nucleophilic substitution reactions of alkyl halides are easier than or happen more easily than aryl halides. Why? You have to write because of the CCl bond acquiring a double bond character due to resonance. Now, supposing on this benzene ring, I have a group like NO2, electron withdrawing group, then the reaction becomes easy because this is withdrawing electrons and this is increasing the polarity of this bond. So if I have, say, 3 NO2 groups, then the reaction will take place more easily. So any electron withdrawing group will help in the nucleophilic substitution reaction on the benzene ring. Okay, so that is one type of reaction. Now, whenever there is a benzene ring, there will be some reactions due to the benzene ring. So those reactions are called electrophilic substitution reactions. Electrophilic substitution reactions. You have learned these electrophilic substitution reactions of benzene in class 11. Okay. So what are the reactions? First is chlorination. Right? What is chlorination? Addition of chlorine in presence of anhydrous AlCl3. So what is the reaction? I have chlorine, I have benzene ring here and chlorobenzene. And I am reacting it with chlorine in presence of anhydrous AlCl3. What will happen? One more Cl has to come on the benzene ring. Now, with the resonance structures I showed you, Cl is what? Ortho-para directing. What does it mean? That the new substituent on the benzene ring will either come on ortho or on para position. So I will get two products. One is like this on ortho position, and the other one will be Cl and another Cl on para position. So this is ortho dichloro benzene and this is para dichlorobenzene. So I'll get two products, one ortho and the other para. This will happen because of chlorination of benzene ring. So whenever there's a benzene ring, a Cl will come on the benzene ring, and where will it come will be decided where on the nature of the substituent. Now, if I have, so we know chlorobenzene is like this. Now, if I do nitration, nitration means reacting the chlorobenzene with nitric acid, concentrated HNO3, in presence of concentrated H2SO4. So what will I get? This is chlorobenzene here. And when it reacts with HNO3 in presence of H2SO4, then what comes on the benzene ring? NO2 comes on the benzene ring. So this is chlorobenzene. And NO2 has to come on the benzene ring which is the position chlorine will decide? Nitro. This is plus para-chloronitrobenzene, right? Two products. One is ortho, the other is nitration. This is known as nitration. Supposing I take the third condition. The third condition is 4 reactions are always there for benzene ring. The third reaction is known as sulfonation. Right? So in sulfonation, what is happening? You have your benzene ring. So on the benzene ring, you already have a Cl. In the same way, now you understand what I'm talking. Concentrated H2SO4. So a SO3H group will come on the benzene ring. So this is Cl. Where will the SO3H group come? This will come on ortho position. And where will it come? Where else can it come? Cl and here SO3H. Right? Two products always. So this one, what is the name of this product? This is orthochlorobenzene sulfonic acid. And the other one is what? Para-chlorobenzene sulfonic acid. This one is what? Para-chlorobenzene sulfonic acid. So you can get products by chlorination, nitration, and sulfonation of benzene ring. Now the last reaction here is of the last reaction is called Friedel-Crafts reaction. Friedel-Crafts reaction. So what is the Friedel-Crafts reaction? In the Friedel-Crafts reaction is also of the benzene ring. So you have the chlorobenzene here and you reacted with CH3Cl in presence of AlCl3, which is anhydrous. Then Hariharan, now you tell me. I told you all the answers. Now what will you get? In this case, what is the product that you will get? Now on the, where will CH3 come? CH3 has to come on the benzene ring. Where will it come? It will come on which position compared to chlorine? Where will it come?
Ortho.
Ortho. So you will get CH3 here, plus you will get here Cl and CH3. So orthochloromethylbenzene and parachloromethylbenzene. Methylbenzene is also called toluene. So sometimes we call it orthochlorotoluene and this is parachlorotoluene. So these are various ways by which you can have reaction on the benzene ring. Reaction on the benzene ring is known as electrophilic substitution reaction. Reaction on where the chlorine is substituted, that is called nucleophilic substitution. So aryl halides can show two types of reactions. Reactions at the benzene ring and reactions due to chlorine. So all these reactions we have learned. Now we have finished our aryl halides also. Now the last part of your chapter is all the important other compounds of halogen derivatives, other halogen derivatives. So one of the very important halogen derivatives about which I talked in the beginning is called, it is trichloromethane and also known as chloroform. So I already talked to you about chloroform. It is one of the first anesthetics that was used for anesthesia because it makes you unconscious for some time. And it has many side effects. What is one major side effect because of which chloroform is not? It is used as an anesthetic. There is one side effect because of which we don't use it now, because chloroform, we say it is stored in dark bottles. It should be always stored in dark bottles, filled up to the brim. Bottles filled.
Fasting gas.
Filled up to the brim, right? Why do you think we should fill it up to the brim? Yeah.
Because chloroform reacts with oxygen to create fasting gas.
Yes. So chloroform, CHCl3 plus oxygen, right? So it forms COCl2, right? So the COCl2 is a phosgene and it is extremely poisonous. So we have to keep it because oxygen and because in presence of sunlight, it decomposes and forms phosgene. And phosgene can, you breathe the phosgene, and so when they give it to the patient to breathe, they think it is chloroform, but the patient is actually breathing phosgene. He will never wake up. So we have to be very careful here. So that is why, since it was very difficult to have pure chloroform, it readily changes into phosgene. So you have to always test, because when you test phosgene, chloroform does not give a white precipitate with silver nitrate, but phosgene does. So that is why there are different tests to find out. But chloroform, this question is always asked and give reasons why chloroform is stored in dark bottles filled up to the brim to prevent the formation of phosgene. Then the other reagent that we are very commonly we use is iodoform. Iodoform is a this is a liquid which is has a sweet smell. Iodoform is a yellow solid, right? And it is a very good disinfectant, largely very cheap and good. It is largely used in the hospitals for disinfection. Then the third compound of halogens, which is very common, is these freons. Freons are chlorofluorocarbons. So CF2 and Cl2, this is freon. So freons, they are very good refrigerants. Okay, they are very good used for refrigeration. Okay, so they are very good refrigerants. So what is the problem of chlorofluorocarbons? They release a lot of free radicals in the atmosphere. And because of those free
Ozone layer.
radicals, their ozone layer depletion is there. So there is a problem of the ozone layer. Now there is one more very important compound of halogen derivatives, which is DDT. DDT is dichloro. I told you in the beginning, dichloro, diphenyl, trichloroethane. Trichloroethane. I think you don't need to know the structure of this compound. It is a very important insecticide. But it is non-biodegradable, so it causes a lot of pollution in the water, in the rivers. With the rain, it goes into the rivers, and fish, it gets into the fishes, and through, if you consume fish, then it will come to you, and it can be very poisonous. Now, what is the structure? Let me show you, although it is not there in our syllabus. So this is diphenyl. And this is dichloro, diphenyl, and this is trichloroethane. So CCl3, CH3. Dichloro, diphenyl, trichloroethane. This is the compound. Trichloroethane. Okay, so this is DDT. So these are important compounds of halogen containing, important halogen containing compounds. So we come to the end. Now, if you look in your textbook, you will realize there are loads. This chapter has a very, very big exercise, loads of questions which are given at the end of the chapter. So they are very, very good questions, and we have to learn to practice them. We have to practice answering those questions. The best ways that, since there's not much, I mean, some of you have not even started the school, so you have enough and plenty of time during the day. Practice doing all the questions by yourself. If you do the questions by yourself, you will be able to do very well in organic chemistry. Do very well in organic chemistry, you have to practice a few questions. So what I'll do is I will do one or two questions from your textbook, because there are 10 more minutes. These are all questions on what you call conversions. The ability to, whether you have understood everything or not, depends on whether you can do a conversion properly. Okay, so I will just take your book, just 1 minute. All of you have got, no, the NCERT textbook? Yes or no?
Yes, ma'am. Yes, ma'am.
Yeah. So all of you, please try out these questions. And I would like to hear, first of all, you have to do the assignment. Then after that assignment, we will have 1 day of test. And if there are any questions on the assignment which you are not able to do, please let me know. Oh, my book is not. Okay, so I will take the questions. I have done almost everything. It's also done, this also done. Yes. Dichloro, trichloro. There is one carbon tetrachloride also, which is very, very good solvent. Okay. Now we will start with the conversions. So the first conversion, we are doing question number 10.19. 10.19. So the first conversion here is propene to propan 1-ol. You have to convert propene to propan 1-ol. Okay, so what is propene? CH3, CH double bond, CH2. And from here, I have to make propan 1-ol. So how will I do? I can't add water to propene, because if I add water to propene, then what will happen? I will get 2-propanol. So I have to first step. When you are doing conversions, no, you don't have to write the whole reaction. You just write the reagents on the arrow. So first you have to add HBr. And Br I want on the first carbon, so I will have to add peroxides. So what will I get? CH3, CH2, CH2, Br. And then Br, how can I replace it with OH? Aqueous KOH. So this is the first one. Now look at the second one. Second one is 1-bromopropane to 2-bromopropane. 1-bromopropane. From that, I need to make 2-bromopropane. So how will I do? 1-bromopropane is CH3, CH2, CH2, Br. From here, I want to make CH3, CHBr, CH3. So what will I do? I will have to convert it to propene first. CH3, CH double bond, CH2. How will I do that? Dehydrohalogenation. So alcoholic KOH. And then I will add HBr. I will get 2-bromopropane. If I add HBr without peroxides, I can get 2-bromopropane. Then the next one is the third one. The third one is ethanol to ethyl cyanide. Ethanol to ethyl cyanide. These are all 2 steps. Okay, so what is ethanol? CH3, CH2, OH. From this, what do I need to prepare? CH3, CH2, CN. Right? So I don't know how to make it from alcohol, but I know how to make it from alkyl halide. So first I will change it into alkyl halide. How? I can make it into CH3, CH2, Cl, and then that will change, give me this. So how will I make this change? First I'll use PCl5. What does PCl5 do? It changes OH to Cl. And then I will change Cl to Cn. So what will I do? NaCN. Now here I want to also tell you how to name this compound. This compound, easily you can give it IUPAC name, which is ethyl cyanide. Do you know the, no, this is a common name, ethyl cyanide. Do you know the IUPAC name of this compound? Any one of you? Can you tell me the IUPAC name of this compound?
Ethyl cyanide, ma'am.
No, 3 carbon atoms are there, no? So it will be called propane nitrile. Okay, so when you are doing conversions, you should understand propane nitrile is same as ethyl cyanide. Ethyl cyanide is a common name, right? This is a common name. And this one is propane nitrile is a IUPAC name. So that is. Then the next one is chloroethane to butane. Fourth, chloroethane to butane, right? This one you can guess. Vaishnavi will tell me this is her favorite one, CH3, CH2, Cl. From here, I want to make what? CH3, CH2, CH2, CH3. I want to make an alkane with double the number of carbon atoms. Which reaction will I use? Wood's reaction.
Wood's reaction.
Yeah, and what will I write on the arrow? Na and dry ether. Right? You know, what is this letter? What is this letter? W, isn't it? What is W? W is U and U. W, isn't it? That's why we call it W. So here, remember, Wood's reaction is W. That means you are doubling the alkyl. R. This is U, you make R. All right. So thank you very much, children, for patiently listening to me. But I can take one more class on just discussing the various questions, but that I will do in case you tell your coordinator that you need practice on more. Because I finished the theory. Now, knowing the theory doesn't really mean anything. If you understood the theory, you should start answering the questions. So by next Thursday, I should know what are your problems. So you please convey your problems and doubts to your coordinator so that they can convey it to me, and then we can decide what to do in the next class. I will teach the next topic only when I am confident that you are all thorough with what I have taught you. All right. Okay, then see you on Thursday. Bye.
Thank you, ma'am.
Bye.
Thank you, ma'am.